down. So roughly there. And slightly bigger than what we started with. All right, so this is 112.5 centimeters. So the rule of thumb, image of lens 1 equals object of lens 2. So now we go about solving this thing for the second image. Again, we have 1 over the object distance plus 1 over the image distance equals 1 over the focal length. We're dealing with image 2 now. Focal length is erased now. Oh, there it is, negative 30. So I got 1 over negative 30. What is the object distance?
The second one?
Yes.
112.5?
No. That's where the image is from the first lens, but that's not the image distance to the second one.
97.5 centimeters.
That is, this is the object for the second lens.
I see.
So 1 over, what'd you say again?
97.5? 87.5.
Okay, 87.5 plus 1 over distance of image equals that. And so what is the image distance?
I got negative 22.34.
Negative 22.34.
That's what I got.
All right, got 2. Do we have a third?
Oh, negative 22.34.
Okay. Negative? All right, so that means, where is that image going to be? If I'm treating this is my object here, and that's my lens, and I get negative 22.34, where is that image going to be?
Yeah.
That. I've got right toward over here.
Yeah. Maybe.
Anyone want to back Christian up or stand up and criticize his upbringing?
I do that by myself very well.
Please don't.
One of my favorite lines from a movie came from good guy talking to bad guy at the end and saying, I was a bastard from birth, but you're a self-made man. Way to be a self-made man.
I do what I can.
So Christian is willing to stand out there and make a statement about where he thinks it's going to be. Anyone want to back him up or refute him?
I'll back him up. Yeah.
Thanks, sir.
Yeah. What was the question again?
Where is the image going to be? We got a negative 22.34, so the question is where it's going to be. So Lisa's willing to say it's on this side. We got Christian and Curtis saying it's on that side.
Standing with you. Still with you.
I appreciate that. Maybe
Oh, thought Wayne was about to say something.
No.
All right, anyone else? We got 3 people willing to speak up. Go for it. Willing to bet their entire grade on this one question.
Oh yeah.
I like the confidence.
Nobody?
If it were not for your entire grade, what would you say?
Just for half of it.
All right, let's see if physics by democracy works.
Yeah.
I imagine at this point you have a gut feeling. Don't base your answer on what other people say. Base it on what your gut feeling is. So we've got the lens here. So the question is, I guess we have 3 regions. We got region 1, region 2, and region 3. So the question is, the final image, region 1, region 2, or region 3? All right, who says region 1? Region 2? Region 3?
Yeah, I'll stay with Christian.
And there are 2 people who did not answer, I believe. Kevin and Tristan are playing back. Make a stand.
Region 4.
There is no image. It's a Zen question. Kevin, Tristan?
Region 2.
Kevin?
I'll go 3. Attaboy. Just keep it.
All right, so everyone took a stand there. We do have a majority rule, and it turns out the majority is actually correct. So, it is
Christian.
over here.
It's a single ship. I'm sorry. Can't all go down the ship.
I know, and I do appreciate your willingness to go out on a limb there.
I just put 3.
Remember, we have an image here, we have a lens here, we have a negative image here for the lenses. These are lenses here. So negative image means virtual. The light is coming in, the light, if you think of this as an object, the light comes in and splits apart. So the light is not going to meet on this side over here. So since the light is not actually going to meet, it only has the illusion of meeting, then the image is going to be on this side. So this was 87.5, so it's going to be somewhere over here. Now magnification. What is the final image relative to the initial image, or initial object? Well, William?
I have a question. Is that like the projector? Like a projector? How you would see it, the light, you see the light, but you actually see the image on the...
Oh, if you looked up at the actual lens itself? So if you treat this as the lens here, projecting an image onto the screen.
Well, no, wouldn't the lens would be the second one. The diverging one.
I was thinking, this would be the lens there, and this would be where the screen is focused. And then what you're looking at there,
because it kind of shoots out, but then you can kind of see the image on there.
so the question is, does it appear that the image is behind the lens there or in front of the lens? I was wondering if this was more like your eye.
I thought that would be the lens for the projector.
It does spread apart. Except the fact that the light is actually hitting the board there. I'll have to think about that longer. I'm feeling like I'm in that zone where I can rationalize almost anything. So let me take a step back from that. Let me write down the question. Yeah, let me think about that moment. All right. Now the magnification that we're looking at here, it's just basically, what's the magnification for the first bit? So magnification 1 is negative 112.5 over 90. Classic image distance over object distance, which is some number. Magnification 2, we start out with an image that is whatever that size is. Magnification 2 would be negative 22.34 over 87.5, which is a positive number. The total magnification is just the product of the magnifications. So I got -1, so the total magnification, -1, 12.5 over 90 times 22.34 over 87.5. Notice the minus sign disappeared from the second one because they canceled out. I have two negatives here. And we end up with something less than 1.
Do we multiply by the height of the object?
Well, when we're multiplying by the magnification, if that will tell you what the final height will be. But since I didn't give, I guess I gave an initial one right there. We could find the actual height in the end.
-0.319.
-0.319.
So
I think, all right. And so since the original object was 3 centimeters tall there, then, so H image over H object is equal to the magnification. So height of the image would be initial height times the magnification. So 3 times 3 centimeters times that. 579.957 centimeters. What does the negative mean?
Inverted.
Yep. And it's almost the original height. All right. Questions before I make it more complicated? Or do you want another one of these before I make it more complicated?
I said we just jump right into it.
Jump right into it. All right. Well, now put the lenses 100 centimeters apart. The image of the first lens is now on the right side of the second lens. And the question is, how do you deal with that? That changes. When you're dealing with still the image of the first is considered the object of the second. But the question is, yes, we can find this distance here. This is 12.5 centimeters. The question is the image object distance positive or negative now? So when you're dealing with that, it comes down to the convention that you first set up. We started out with the image over here. This is the positive side for the image. The other side of the lens is the negative side. So this object distance is now negative 12.5. And that's how you deal with it. The first case, if you start looking up, trying to find examples of the multiple lens system, almost every single example I ever see has the image for the first lens is in between, and so it's just still a positive distance to the second one. I found it very difficult to find examples where they stuck it over where the image was on the other side of the lens. But you do set up that convention, a positive and a negative there. And so now the image distance is something just absolutely special and magical. So, I was thinking, man, we have more than an hour to go.
If you put that image on the other side now, is the focal length still negative 30?
Yeah, focal length is still negative 30.
Is that just the length of the lens?
Say it again, sorry.
Is that just just the length of the lens, the diameter of the lens? Or no?
The focal length? No, it's
Yeah, 31.
related, it's half the radius of curvature of the lens. Or if it's asymmetric, then use the lens maker formula. Sorry, I didn't know that was sort of a vague answer.
No, I get it now, that's.
Okay. Sorry, radius of curvature of the lens, not the radius of the lens.
-8.8.
Which tells us that the image, because lenses, you expect the light to go through a lens, so if that's the case, and traditionally you put the object on the left-hand side, this is the positive side for object, this is the positive side for image. So that tells us that the image is going to be on this side of that lens, and presumably inverted still. I'm going to attempt a ray diagram. I'm not going to spend the half hour like I did that last time. So
Got 9 minutes now. Yeah, but we have 8 minutes.
I am going to hopefully do better than the crude drawings there. I at least want a straight line. Oh, I'm going to call that close enough. Let's mark this thing off. Let's see, we have to start it out 90 centimeters away. So if lined up-ish. All right, so if I put the first lens here, so the first lens is there, focal length is 50 centimeters away, so if each of these is a 30 centimeter mark, so that's 30 centimeters, 60 centimeters, 90 centimeters, 90 centimeters. Focal length is somewhere around there, close enough. And on the other side, it would be somewhere around there, close enough. I have an object here. And my second lens is 100 centimeters away, so 30, 90, so it should be basically a third of that distance, roughly there. So that's going to be the second lens. And I'm going to call that close enough. So the object comes in. I know the magnification is going to be a little bit bigger than the initial, so shouldn't be going off the board here. That there, and I'm going to call that one close enough. All right, so light that comes in this first one is a focal length of 50 centimeters. It should focus on the focus. This is light coming straight in, so it should go through this point right here. Light that goes through the center should keep going in a straight line. Notice that they are meeting on the other side of the second lens, which is what we expected. That image should be a little bit bigger than the initial object, and it looks roughly like it is on the other side. Now, whether that would match out to 12.5 centimeters beyond it, we'll just assume I did it perfectly. Now, the important one here, though, the one that really gives a clue about where the final answer is this one here. So light that goes through the focal point. What happens to light that goes through the near focal point? What happens when it gets to the lens?
We go through the next focal point.
Oh, because it bounces up like that?
Yeah.
No, I hope not.
Okay.
It bends a little bit.
How much? Recognize there's a symmetry. Stuff that goes in parallel will go through the far focal point. Stuff that goes to the near focal point.
Would it be parallel with the?
There you go. Yeah. It'll be parallel. And obviously, my drawing skills are just spot on. So let's cheat a little bit and put it somewhere around there. Light that comes in parallel to a diverging lens is going to do what? So we have a actual light ray that comes in, goes across this through the focal point, then should come out parallel. When a parallel light comes in, hits a diverging lens. This is the focal length of, is it negative 30 centimeters? What does the light do when it hits a diverging? All right, it'll spread apart, so which direction should it go? Besides away.
I guess the bottom one would go down and the top one would go up, like,
So this would go down like that?
I guess so.
Okay, it will.
Okay.
It will go down like that. The question is, how would you actually draw it if you were being inattentive about it? Sort of doing an opposite of what we have over here. Here it comes in parallel, goes to the focal point. Goes to the focal point, goes out parallel. For diverging lens, if it comes in parallel, it goes away from the focal point. So the focal point here is somewhere around there. So the light that comes in parallel right here should go away from that focal point. So the actual light ray, this is the path, this is the one light ray that we don't have to play around with too much, that we know that this going through the focal point is going to hit that, go parallel, hit the second lens, and then spread apart. The final image needs to be somewhere along this line right here. The final image has to be along that line, because that's the actual light. It's either going to appear where the light rays virtually meet, or it's going to be where the light rays actually meet, but the final one needs to be somewhere along here. And this is so badly drawn at this point. This is why it gets way too complicated. Yeah. Yeah, this is where all the little mistakes start adding up. Let's see if I can salvage it at all. So this focal point is here.
I had a different number for DI.
Oh, what'd you get?
I got 0.047.
So you had, let's see, because I moved this to 100 centimeters, so that's 12.5. So it's 1 over negative 12.5 plus 1 over image distance is equal to 1 over negative 30. And you had, that's after you take the reciprocal?
21
That's what I got.
So I did it 2 ways and I got both of those.
You got both of them?
Yeah.
Okay.
So I know, I guess the difference is I did plus and you did subtraction.
Yeah, you did plus and you get the 8.8. But it's gotta be negative, and you get the 21.
So 1 over DI is equal to negative 1/30 minus negative 1 over 12.5. So we should end up with, well, that's smaller than that, so we should end up with a positive number.
Yeah, 21.
All right, so the final image will be on that side. All right. That's making more sense now. My drawing's not as far off as I was thinking. So the final image will be at an intersection of this line right here, and to me, the simplest one is the one that goes through the center. So connect center and end point right there. And so the final image would be somewhere around there. It is a positive image, so it's going to be over on the side. I guess that's whatever. So now if we look at magnification, magnification for the first one is negative 112.5 over 90. Magnification for the second one is negative 21.43 divided by negative 12.5. So we ultimately end up with a negative magnification, so it is inverted in the end.
Negative 2.14.
And the final image is real, as it so happens. Because the final image is on the right side of everything, which is what you would expect for light going through a lens. Questions?
So at our final image, it would be smaller, right? Like
The final image should be more than 2 times what we originally started with.
Oh, it'll be bigger.
Pardon?
So it'll be bigger.
Yes, it would be.
Oh, okay. Oh, just, okay, never mind. I see.
And then if you, this is sort of my attempt at it, I'm assuming that your vision is just absolutely perfect. We have the object here, it goes through focal length of 50 centimeters, focal length of negative 30 centimeters, and the final image ends up being here in this particular case. I've got different numbers. Let's see, I had them 100 centimeters apart. 50, negative 30, 100 centimeters apart. So why do we have different numbers here than what we have written on the board? Oh, because it's 90 centimeters away. That's the difference. I had it, in this problem right here, the object is 60 centimeters away instead of 90 centimeters away. So, and then, for the camera, and potentially this will all be backwards on the camera, or perhaps sideways. But you know what this means, though? We're done with chapter 36.
I know, I was hoping it would go on a little bit longer.
I want you to have, somewhat of a vacation there. How many of you actually get a vacation, or does it just mean you're working more hours? Working more?
Just working more hours.
I assume it's work where you can study while you're working? Security guard, whatever
No, I wish.
or parking lot attendant, I guess, security guards. The classic TV image is they sit around looking at monitors, but I don't think that's actually the case.
They said, look at their phones.
Is that?
They said, look at their phones.
Look at it. Have any of you ever seen the movie, The Parking Lot Movie? It's a documentary about a parking lot. And you would think, my gosh, how boring can that be? It's actually really well done. But the guy who owns it said, I like hiring the philosophy majors because they're the ones who can sit there and do absolutely nothing for hours at a time. If no one's coming in, there's nothing to do. And they sit around and they just read their philosophy book. March 24th. Back to topic at hand. Chapter 36, I believe. 35, that quiz is on Monday. 36 is the lens. And yeah, 37, we get into interference. And then at the end of 37, we're done with the course. No, at the end of 37, then we start doing other things. Because in terms of the actual content of the course, this is light and sound. This textbook basically does light through chapter 37. So then I will go into topics of physics in which we will hopefully learn, you will learn to question anything you've ever been taught in physics. Someone once described school as, first they teach you what, then they teach you what and why, and then they teach you, or what and how, and then what, how, and why, and then they run out of things to teach you, so they teach you to question anything you've ever been taught. So, that fate is coming up. But the other question is, right now, last semester, I did light and quantum together in the final test. So the question becomes, do you want another test in there? So there's 3 tests this semester instead of 2. That doesn't have to be decided right now.